Hello guys, you're welcome to my YouTube channel. Today I'll be looking at this question. The question says solve log 3 exponent x plus log 9 exponent x is equal to 12. So I'm going to solve this question in two ways. The first one will be log 3 raised to the power of x plus log 9 raised to the power of x is equal to 12. So the first method looks simpler than the second one, but let's see. So now I'm going to consider this log 9 raised to the power of x. So what I want to do here is to make sure to make log 9 raised to the power of x to be of the same base with log 3 raised to the power of x. That is the first step. So I'm going to write this thing like this: log 3 raised to the power of x plus log, 3 raised to the power of 2 in mathematics is 9. 3 raised to the power of 2 is 9. 3 times 3 is 9. So that is the first step. So the next thing is to apply the power law of logarithm. Power law ordinarily, if I'm using this exponent, this is the exponent here, this exponent here, it's supposed to be x log 3 raised to the power of 2. That is, this x moved to multiply the log itself. But if there is a number in between, you want to move out, you want to move from the position, like these two in between x and 3. So I'm going to use the reciprocal of this to multiply the log itself. That is the law. If you are using x to multiply log itself, it's going to be x log 3 raised to the power of. That is the power law. But if you are using the number or letter in between the base and the exponent, the highest exponent, it's going to be you're going to multiply the log with the reciprocal of the number. That is this 2 here. I'm going to multiply this log with the reciprocal of 2. Reciprocal of 2 is 1 over 2. So that is the law. This is going to be log 3 raised to the power of x plus reciprocal of 2 is half, 1 over 2 log 3x. The reason I use 2 is because I want to obtain something that is the same with this. You can see log 3x is the same with log 3x here. It will make it easy for simplification. Now this is equal to 12. So you can see log 3 raised to the power of x is here and also is here. So it means it's a common factor. I'm going to factorize this expression, this logarithmic expression. I'm going to factorize it. So doing that, this becomes log 3 raised to the power of x. I'll put brackets. Then 1 will be here plus, then half will be here. Okay, this and this are the same because if I expand the bracket again, I'm going to have log 3 raised to the power of x times 1. It will give me log 3 raised to the power of x. Then log 3 raised to the power of x times half is going to give me half log 3 raised to the power of x. So this and this are this. I just did factorization. So I'm going to equate it to 12. So the next thing to do is to solve this, to add 1 to 1 over 2. Okay, this is fraction. So it's going to give me log 3 raised to the power of x bracket 3 over 2. So let me explain how I got 3 over 2. If you add 1 to 1 over 2, it's going to give you 3 over 2. This is how I did it. 1 plus half is supposed to be, this is fraction. Make this one to have a denominator as well. And the LCM of 2 and 1 is 2. So 2 divided by 1 is 2. 2 times 1 is 2. Plus, this is how to solve fraction, to add fraction. 2 divided by 2 is 1. 1 times 1 is 1. You can see 2 plus 1 is 3. Divided by 2. 3 over 2. You can see if you're adding 1 to half or to 1 over 2, it's supposed to be 3 over 2. Now, so I will equate this thing to 12. Okay, the next thing to do, because this 3 over 2 is now the coefficient of log 3 raised to the power of x, So what I need to do is to divide both sides with 3 over 2. Dividing both sides with 3 over 2 is going to give me log 3 raised to the power of x is equal to 12 divided by 3 over 2. 12 divided by 3 over 2. Okay, let me write it out. 3 over 2. Okay, now I will continue here. So this is log 3 raised to the power of x is equal to, now this is fraction, 12 over 2, 12 over 1, sorry, that is the denominator. And this is 12 divided by 3 over 2. So in fraction, removing this division in order to simplify this, I'll put multiplication times. Remember that multiplication is inverse of division in mathematics. So since it's inverse, 2 is going to go up, 3 will come down. So 2 becomes the numerator now, 3 becomes the denominator. You can see how this thing changed. So, and I can simplify now. You can see 3 cancel itself, 1, 3 cancels 12 is 4. That's 3 divided 12 is going to give me 4. Okay, 4 times 2 is 8. So I now have log 3 raised to the power of x is equal to 8. Now, okay, there's another way you can do this. You can say 12 times 2, that is 24. 24 divided by 3, it will still give you 8. So I have log 3 raised to the power of x is equal to 8. So I'm going to use exponent law to solve this, to find the value of x. Now, this is going to be, then I'm going to write 3, that is this base. Okay, then this number 8 becomes the exponent, then x comes down, then the log disappears. That is the law. I've been using it here. So this is equal to, x is equal to 3 raised to the power of 8. If you check calculate, that is 3 times 3 times 3 times 3 into 8. It's going to give us 6. If you check it in calculator, it's going to give us 6561. 6561. So the value of x here is 6561. So this is the first method. I'm going to check this question again with the second method. So solving this question with the second method. So I will consider log 3 raised to the power of x. Now, introducing change of base, trying to make this log to be of the same base with this. That is, this is base 9. So that is going to be, I will introduce 9 as the new base. 9 raised to the power of x divided by log 9 raised to the power of 3. That is the change of base. This and this are the same. I just introduced a second base, a new base. The goal is to make the log to have the same base with this. So I'm going to write plus log 9 raised to the power of x is equal to 12. Now, what I need to do, this is log 9 raised to the power of 3. What I need to do is to solve this out. So remember that this is the same thing as log 9 raised to the power of x divided by log. If I write log 3 here, 2. Remember 3 raised to the power of 2 is 9, then raised to the power of 3. So plus log 9 raised to the power of x is equal to 12. So what I'm going to do here is to multiply the log itself. There's a power law. Multiply the log itself with the reciprocal of 2. Reciprocal of 2 is going to give me, so the goal is just to have log of its own base here, which will give me 1. Because if I remove these 2 here, I'm going to have log of its own base, log 3 raised to the power of 3. That will, and log of its own base in laws of logarithm is 1. So this is going to be log, I'm going to write it here, log 9 raised to the power of x divided by half. Remember, this reciprocal of this will multiply the log 3 raised to the power of 3. So plus log 9 raised to the power of x is equal to 12. Okay, let me explain this further. If you don't want to do like this, you can use exponent law by writing log 9 raised to the power of 3, equate it to any letter. Maybe let me use y. So using exponent law, so y becomes the power of 9, then 3 comes down, log disappears. And you know that in indices, this is 3 raised to the power of 2, y. 3 raised to the power of 2 is 9. Then that 2 multiply the exponent, that is y. So I'm going to have 3 raised to the power of 1. You know, 3 raised to the power of 1 is 3 in indices. So you can say this will cancel out this. You pick the exponent, which is 2y is equal to 1. So making y the subject of the formula becomes 1 over 2. You can see how I got 1 over 2. Okay, because this log 3 will give me 1. And at the end of the day, 1 times 1 over 2 is going to give me 1 over 2. So whichever way is the same. Okay, now I'll continue. So bringing this, I'm going to have log 9 raised to the power of x divided by, remember I said that log of its own base is 1. 1 times half is half. So I'm going to have 1 over 2 here plus log 9 raised to the power of x is equal to 12. So what I need to do here, log 9 raised to the power of x divided by half is going to give me, remember this is division, so the inverse of it, 2 will go up, 1 will come down. So it's going to be 2 times log 9 raised to the power of x. So this and this are the same, plus log 9 raised to the power of x is equal to 12. Okay, you can see this. I have the same base here. This is log in base 9. This is log in base 9. So that is the goal. Now what I need to do here is to factorize, because there is 2 here, there is 1 here. So the common, this is log 9 raised to the power of x is common. So it's a common factor. So I'm going to bring it out. So I'm going to write log 9 raised to the power of x bracket 2 plus 1. You know why? Log 9 raised to the power of x multiplied by 2 is going to give me 2 log 9 raised to the power of x plus this times 1 is going to give me log 9 raised to the power of x. So it's the same. I just factorized it. Okay. So this is going to give me, I just clean up. This is going to give me log 9 raised to the power of x times 3, because 2 plus 1 is 3. So I'm going to write log 9 raised to the power of x is multiplied by 3 is equal to 12. Remember that this is 3 log 9 raised to the power of x is the same, equal to 12. So I'm going to divide across with 3. Okay, dividing across with 3, that is the quotients of log 9 raised to the power of x. I'm going to have log 9 raised to the power of x is equal to 12 over 3 is going to give me 4. Okay, using index rule, so this is going to be 9. I will write 9. Then 4 is going to be the exponent. Then yx comes down and log will disappear. So this is the same thing as x is equal to 9 raised to the power of 4. If you check your calculator, it's supposed to be 6, 5, 6, 1. Just like what I got using the first method.